Hello, beautiful people, and welcome to Teaching Sylvanas Math. This is my new website, and I'm super excited for it. Go ahead and log into Teaching Sylvanas Math. You don't have to log in, you can just type it into your Google. Teaching Sylvanas Math, you're going to come up to this screen here. If you would like to go directly to my YouTube channel, you can click here. If you want to meet Sylvanas, which I highly recommend that you do, she is adorable. Look at her. She is fantastic. You can meet her there. We're going to go back to the home screen, and we're going to click on Integrated Math 3, since this is an Integrated Math 3 video. And you get to scroll all of the beautiful and wonderful videos that I tried super duper hard on just for you. And then if you click on a video, it should take you directly to it. I'm not going to do that since I want to spend my time on the new video that we are recording. So let's go ahead and get started. Again, disclaimer, I am human, so if I make a mistake, I apologize in advance. Just let me know where the mistake happened so that way we both can learn from my errors. Also, we are at home today recording due to the scary pandemic that is happening right now. So if you hear a loud noise, I apologize in advance. That is my kitty cat, Sylvanas, running around because she has never seen sun apparently before. It has been raining the last couple of days, so she's super excited for the sun, and she has been running around the house very energetic. All right. But enough about my cute cat. Let's go ahead and get starting about logarithms, rewriting and evaluating. And I just noticed in that title, there is a bunch of typos. That's okay. We're going to shift that page up so that way we don't actually see it. All right. Let me get this out of the way for you. Or I can just shift my paper. That would be smart. All right, let's get started. Evaluate each expression. If you are getting your calculator out, do not do that. Okay, don't do that. Don't rely on your calculator. Logarithms are just exponents, okay? So I'm going to write, oops, sorry about that. I'm going to write something down in a thinking bubble, and that is your holy grail for logarithms, okay? I will even do it in the middle. Log base b of a is x. Now these right here, the b, the a, the x, they can change all the time depending on what book or what teacher you have. But I use log base b because the b represents the base, the x represents the exponent, and then a represents the rest of it. So easiest way to do that, I'm going to even add something. So log base b of a is equal to x if and only if b to the x is equal to a. Memorize that. Again, holy grail. Easiest way to evaluate is just to rewrite it. So if you have log base b of a, we can rewrite it here. This is log base b, so I'm going to rewrite it as an exponent, so 5. We don't know what the exponent is. There is no equals to something. So I'm going to say x, and that's equal to 25. So 5 to what power is 25? Well, that's just 2. Let's try again. Don't use your calculator. Don't touch that calculator. Let's try again. Log base 3 to 43. So 3 to what power is 243? Now, on this one here, I understand it's a big number, so sure, you can use a calculator, but don't evaluate this. So one thing that's tricky about calculators, and some fancy calculators are able to do that, but the majority will not. Oh, I got lucky, the first number I typed in. So 3 to the 5th power is 243, so that means x is 5. Now, I am saying x is 5, I'm saying x is 2, so what we could do is log base 3 of 243 is 5. You can write it this way, and instead of having x for number 1, you can say it is 2. Since I am writing in a variable to equal. I'm going to have my answers this way, but that's fine as well. So what I was saying is calculators do not, most of them, unless you have a fancy calculator, do not have this change of base for you to fill in. Most calculators are going to only have the common base, and the common base is base 10. So if this base is any number other than 10, your calculator will spit out a wrong answer because it's assuming that you have a base of 10. None of these are a base of 10, so don't use your calculator unless you get a big number like this. But don't use your calculator, just rewrite it as an exponent. All right. Another way is, how do I rewrite these things? So I'm going to show you. Let's put in that variable. Let's put in that x. And the easiest way, let's just keep that title hidden, is counterclockwise. So counterclockwise, like that. And when you have counterclockwise for your arrows, that's how you're going to rewrite it. So base is 3, exponent is x, 81. And I believe that is 4. That is 4. So x is equal to 4. So let's do this one. This is getting a little more difficult because if it's a fraction, don't let that scare you. 2 to what power is 1 over 32? Well, first of all, we have a fraction, so I know that I'm going to have a negative exponent. I know I have a negative. And then just look, 2 to what power is 32? So 2 to the 5th power is 32, so I have negative 5. Again, how did I do that? Let's try this. You can also do it a different way. 2 to the x is equal to, let's rewrite this. I have 2, just kidding, 32. To the negative 1 power. And again, how did I do that? I rewrote my fraction. If you don't believe me, type into your calculator 32 to the negative 1 power. It's going to give you a decimal, but if you do 1 over 32, your decimal, 1 divided by 32, your decimal should match. So the negative just tells you that this base right here belongs in the denominator. Okay. After that, I'm going to rewrite 32 as a base of 2. So 32 to what power? Just kidding. 2 to what power is 32? And we said 5. We still have that negative 1 as an exponent. So I have an exponent raised to an exponent. So I have 2 to the x is equal to 2 to the negative 5th power. 1-to-1 property. So x is equal to negative 5. Now you didn't have to do it that way, but if you wanted to do those steps, you have those steps for you. All right, let's do this one. Again, counterclockwise. So 6 to the what power is 1. The only thing that works here is 0. We have 0. Again, counterclockwise. 7 to what power is 1 over 343. Again, if you want to use these steps, you can. If you see a fraction like this, you know automatically that you're going to have a negative. That means it's in the denominator. So now we just need to figure out 7 to what power is 343. Again, big number, so I'm okay with the calculator here. 7 to the, let's take a guess, to the 5th power. Ooh, that's way too big. 7 to the 3rd power. That works. So now we have x is equal to negative 3. Again, let me show you this method. So I have 7 to the power of x is equal to 343 to the negative 1. I'm going to rewrite 343 in terms of base of 7. We have a power of 3 to the negative 1 power. That means I have 7x is equal to 7 to the negative 3rd. 1-to-1 property. That means x is equal to negative 3. All right, let's move on to number 7. Rewrite each equation in exponential form. We have been doing that. So this should probably take you like 10 seconds max. But let's take it back again. Since you don't have it in front of you, I'm going to write our holy grail here. Log base b of a is equal to x if and only if b to the x is equal to a. Now, one thing I do want to point out, what I have been seeing is a little bit of a glitch on how you guys are writing this. So I'm going to draw a line. So this is like your line of a piece of paper. This base B is smaller and lower than your A, X, and your log. Just like this is your line, your X is smaller and higher. Okay, so do not write your B and your A in the same line, and do not have your A floating as an exponent. Don't do that. Make sure it's written this way. All right, again, counterclockwise. We are rewriting each equation in exponential form. So we're going from here. What do we have? We have logarithmic form. What do we need? Exponential form. Okay, so counterclockwise, 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 counterclockwise. You're pretty much done. So 15 squared is 225. 5 to the negative 2 power is 125. 1 over 25, excuse me. 1/13 to the second power is 1 over 169. 256 to the 1/2 power is 16. Told you, 10 seconds. If you have this memorized, your holy grail, you're fine. Let me scooch this up just a little bit. There we go. Okay, rewrite each equation in logarithmic form. So let's do that. Holy grail, we can kind of see the end of it, but I'm going to rewrite it again. Holy grail, log base b of a is x if and only if b to the x is equal to a. Now, what do we have? Exponential. What do we want? Logarithmic. So now we're going from here to here. But going counterclockwise, just like we did from logarithmic to exponential, works from exponential to logarithmic. So I'm going to still go counterclockwise. But this time I'm starting out with log. Just to get my arrows out of the way. So log, first thing is base 3, then I'm writing 81, and then I'm writing 4. Okay, I'm going to do that slower. Make sure this is in a line with your 3 smaller and lower. Okay, let's try another one. Since we want it in logarithmic form, you have to write log. Then the first number we have is 13, so smaller and below. Second number we have is 169. And what is a log is an exponent. So is your equals, and 2 is your exponent. So when I say what is a logarithm and you reply a logarithm is an exponent, this is what we're talking about. It is an exponent. Okay, 2 more. So log base 5 of 25 is 2. Log base 11 of 121 is 2. All right, guys, this is the end of the video. Thank you so much for watching. If you have any questions, let me know. If I've made a mistake, I am human. Let me know where the mistake occurs so that way we both can learn from it. Again, check out the website, check out all the other videos, and thank you for watching.